Good evening, everyone, and welcome to this BAFTA Games live stream, live from Creative Assembly. My name is Duygu Cakmak, and I'm a Senior AI Programmer at Creative Assembly, and this is my colleague Csaba Toth. He's a Senior AI Designer working on Total War. We've joined up with BAFTA Games for this live stream as part of their BAFTA Career Games program, which is a network for those currently working in the games industry to have access to BAFTA award-winning talent and nominees. Today, we would like to talk to you about what makes it difficult to analyze and assess the overall quality of AI behavior in complex strategy games such as Total War, and how we tackle this challenge. We shall be talking about 6 sections in total, 3 by me and 3 by Csaba, but the first thing I would like to do is to summarize what Total War actually is. Total War is a strategy game made up of 2 parts. The first part is a turn-based campaign, which can be classified as an empire-building game. If you know the board game Risk, you can find a lot of similarities. For example, there's a large map, which is divided into territories. There are factions scattered around the world, and there are armies fighting with each other. As a player, you control a faction, which has some territories, armies, and enemies. Your goal in the game, very simplified, is to defeat your enemies and to take over the world. The second part of the game is real-time grand-scale battles. Throughout this stream, we will only be talking about the first part, the campaign part. Three Kingdoms is our last release title. It is exceptionally well received and broke all of our previous records. We will be giving examples from this game in this presentation. Total War is a very complex sandbox game. It has a lot of different systems that needs to be managed. For example, the player needs to make decisions to improve their economy in the finance system, to build new buildings in the construction system, or to recruit new units in the army recruitment system. Every other faction in the game has its own AI, making exactly the same sort of decisions the player does in all of these systems. It is important to note that all these systems are interconnected. That means a decision the player or the AI makes in one system will be affecting the decisions that they make in every other system. The second thing I would like to point out is the number of different states the game can be in at any time. In order to show the magnitude of this, I want to do something. I would like you to think about a very simple version of the game. Let's say there are only 40 factions in the game, and each faction has only one army, one territory, and one enemy. And then each faction has only 2 possible actions that they can do: to attack their enemy or not to attack their enemy. Depending on what each faction does, the game will end up in different states. So the number of different combinations of actions each faction can do will give us the number of different states the game can end up in, which is 2 to the power of 39, more than 500 billion. That is a big number, and this big number is the number of possible different states the game can be in for this very simple version of the game, and only for one round. But in reality, Total War is a much more complex game than this. Factions can actually have more than one territory, and they can have many armies. Each army can do more than one action. For example, they can attack to another army, they can defend a territory or recruit in a region, and so on. And the armies are only one resource of one system. There are many other systems in the game, as I mentioned earlier, and each of these systems needs to make decisions on different resources. For example, the diplomacy system needs to pick a good deal to offer to the others. Or For example, in the construction system, a good building needs to be built and so on. And finally, there is not just one turn, but there are hundreds of turns in the game. So the number of possible states the game could be in any time is explodingly high. This complex nature of the game creates a big challenge for us. And this challenge is to see, to understand, and to assess if AI is making fun, reasonable, and challenging decisions in each interconnected system and in every possible scenario. Moreover, during the development of the game, we change some code, they tweak some data, and we need to be able to see how this impacts the game very quickly every single day, so that the changes that we need to make the next day are built on a solid base. So the actual challenge is not only to get a clear picture, but to find a method to show us the clear picture very quickly. So in order to tackle our challenge, we thought we needed a system to simulate how the AI behaves in a very large number of different scenarios. And we needed a quick method to see how good the AI's behavior is in these simulations. For these reasons, we built a set of systems and techniques. The first one I will mention is about simulating the possible scenarios and gathering data. We built an autotest environment that allows AI agents to play the games against each other, and we call these games autoruns. This autotest environment is an automated system which runs many autoruns in parallel in our development PCs outside of working hours. Autoruns simulate the game and provide the data logs along with some useful information about how AI sees these game systems and how it makes its decisions. So, our autotests run day and night, but what sort of data do we collect in an autorun? Firstly, we collect the most important data that would allow us to understand what happened in the game, such as how the region ownerships changed, or how armies moved around, and so on. Then we store this crucial part of the data in a central database. This data helps us to understand many things, but mainly it helps us to identify bugs or balancing problems. But whenever we suspect there is an odd behavior on these logs, we usually need more detailed information, such as what happened in the previous rounds, like 10 rounds ago and so on, that led us into this unwanted situation. For that, an autorun can also produce more detailed logs, which elaborates massively on decisions. An example to such logs would be: how did the warlord Yuan Shao decided to declare war on the warlord Cao Cao in round 10? As there are at least 10 criteria that would contribute to this decision, and there are at least 100,000 diplomatic considerations per game, one set of log data that includes such information can be at least easily 1 million lines. As these are big files, we do not store them globally. We store them in our local machines, and they are generated only when requested. With the help of autotests, we gather a good amount of data. We now, somehow, need to extract meaning out of this data, and we need to present this in a way that it is easy to understand what is going on, so that we can analyze the data very quickly and efficiently. In order to do that, we have developed our visualization tools. There are a few of them, but I will be talking about the main one, which is called the cat. Not this one, this one. Cat accesses the central database, gathers metadata on what type of games played, in which branch, in which change list, and so on. Then, whatever you choose, it links it with the game data, such as battles, region ownerships, armies, and so on. And then, this data, given in the given round on the timeline, is reflected to the map. With the help of filters, you can also focus on one or multiple factions, regions, different type of battles. You can also compare and collate data from multiple autoruns. So, this is our main visualization tool in a nutshell. And now, Csaba will analyze an example autorun and show you the tool in action.
Thank you. Now I'm going to show you how an autorun looks like in CAT, and then we will do a little analysis on it. What we're going to see here is the playback of an autorun where nearly 40 AI-controlled factions played the game for 300 rounds. This is the map of China in year 190, the beginning of the Three Kingdoms main campaign. Different colors represent the various factions in the game. These dark grey regions are unoccupied, while this vast red-brown area is controlled by the Han Empire, which was on the verge of collapse at this point of history, so they are unable to expand or defend themselves. Apart from showing region ownership, we're also going to track the army movements of a very dangerous warlord, Cao Cao. His armies are shown as brown dots on the map, while armies of all the other factions are hidden, so we can focus on his behavior. Now let's see how an autorun looks like. As you can see, everyone is trying to expand. Cao Cao is capturing some regions in the north and then launches an invasion towards the west against the tyrant Dongzhou. He captures some regions there, but he quickly loses them, so eventually he has to fall back. And while he's focusing on launching new attacks to the north and to the west again, another warlord is gaining strength in the south. It's Sun Jian, represented by light grey color south of Cao Cao's domain. As a general rule in Three Kingdoms, growing power means growing threat. So eventually, Cao Cao will launch a preemptive invasion against Sun Jian before he grows too strong. As you can see, the invasion has already started. Cao Cao is gaining a lot of land, and the invasion seems to be very successful. And that's it. That's 300 rounds of gameplay. So what's the use of watching these autoruns? They look pretty cool, but what sort of bugs or balancing issues can we identify with it? To give you some examples, any indecisiveness can easily be spotted using CAT. For example, if an AI army keeps moving between point A and point B without doing anything meaningful, that's a classical indecisiveness issue, and it's an obvious bug, easy to spot in CAT. Or there can be cases where, at some point of the autorun, many AI factions become overly defensive or completely passive, and this is also easy to spot using CAT. With regards to the AI's balancing, by balancing I mean fine-tuning AI behavior, so by watching a few autoruns, we can get a good overview on how quickly the AI expands its empire and how active it is in the game in general. We can also observe how the AI reacts to nearby threats and enemy invasions. We can also assess how strong the various factions are in the game. Is it always the same faction that prevails in every autorun? Or is it too random between autoruns? So there are quite a few questions we can answer using CAT. We just need a clear vision on what AI behavior we expect and a keen eye for spotting irregularities. For this reason, CAT is mostly used by, actually only used by AI designers, AI programmers, and specialized members of QA. When I say AI designers, I mean game designers who focus on AI behavior. And when I talk about QA, they are the game testers. So our QA team also uses our visualization tools to create so-called AI expansion reports. This is basically a summary of which AI factions dominated the game in recent autoruns, supported by screenshots and animated GIFs that show how these factions expanded in these autoruns. Now let's have a look at some less visual ways of analyzing AI behavior and dive into a more in-depth form of analysis using logging and automated reporting. As we established, analyzing autoruns in CAT is useful, but it doesn't provide details on what's going on in the AI's head during the game and why it's making certain decisions. As Duygu mentioned before, CAT is using the central database, and that only stores a core set of AI data with no detail on AI reasoning. So to solve this, we use extensive local logging. So basically, AI developers can enable various types of these AI logs in the game settings and record detailed low-level information during the autoruns they launch while they are playing the game. These logs are focusing on different parts of the AI. We have logs for finance, army behavior, etc. Basically we generate huge CSV spreadsheets, and they store information on how the various AI factions perceived the game in each round of the campaign and how they made certain key decisions. To give you a concrete example, in the autorun we saw earlier, we can check what Cao Cao was planning to do with his armies during his invasion against Sun Jian. To do that, we open the resource allocator log that stores information on the objective of each AI army at any point of the game. Just to give you an idea about how big these logs can be, in the example autorun, the allocator log ended up almost being a 200 megabyte CSV file, and it had about 500,000 rows of entries and many columns. So it's a pretty huge log. If we zoom in that small section of the log and then zoom in some more, we will see data on round 275, which is about the end of the autorun, Cao Cao's faction, and the army objectives that were generated this round for Cao Cao, with the highest priority being on the top. Each row represents an army objective, and it has information on the type of the objective, such as attack force, defend region, or attack region, recruit, etc. The target of the objective, which could be a force or a region, the owner of the target, and the overall priority of the objective. And there are many more columns. I just want to make sure we're showing the most important ones. According to this objective list, Cao Cao was mostly targeting Sun Jian's forces, which makes a lot of sense. But there were also some very high priority defend region tasks as well. So the question is, why would the AI defend with such a high priority while invading an enemy? Maybe this is a bug. Let's check the task generator log. In this log, we can get details on why the AI picked those objectives for its armies and how they ended up with that priority. The highlighted area shows the defend region task we found earlier, and the last column explains the main reason why the AI picked this target. It says defend recently captured territory. So that makes a lot of sense, as in Total War games, when you capture a settlement from the enemy, its defenses are minimal at that point, and it takes a few rounds to build up a garrison force, so it's worth protecting the settlement for a while. However, this priority still seems to be unreasonably high for Cao Cao's AI personality. So at this point, this is either a bug and the AI is using incorrect values, or it's a balancing issue. When I was looking into this bug, I quickly realized that this was actually a balancing issue because the AI was using the correct value, but the value was set to a too high number simply. So I had to tweak it back and this is how we fine tune AI behavior. So the vast majority of bugs and balancing issues related to AI behavior can be found with these logs. These logs are extremely useful if you know what you're searching for. This is why proper visualization like the CAT tool is essential. CAT gives us hints on where things might be going wrong, while these logs help us figure out why and how. Yes, so on Three Kingdoms, this detective work was done by AI designers because analyzing AI behavior is part of our daily routine. And from time to time we ask the question, how can we improve the process of analyzing these logs? One improvement could be to make the spreadsheets look less boring. I would love that. But on a more serious note, we could potentially add support for loading these logs into CAT and visualize it, use infographics, etc. So imagine these army objectives being displayed on the map as arrows. That would be very, very good. That would be a nice improvement. So this is pretty much how we use logs, but we're not done yet. For the next method of AI analysis, we will go back to the concept of the central database Duygu mentioned before. And this method is automated reports. What's an auto report? It's a system that automatically runs SQL queries on the central database, where we store the core set of AI information, every day, generates a summary, a spreadsheet, on the most important metrics of those games, and automatically sends it around in an email. It looks like this, another boring spreadsheet, with lots of potentially interesting information. Each row shows a set of average data taken from autoruns that were using a specific build of the game. It shows things like how many factions were alive at round 50 on average, how big the AI's armies were at round 50 on average, how many armies and units the AI have recruited up until round 50, and many, many more. We have a lot of metrics here. With this, we can easily spot and flag up extreme values and compare data between different builds of the game. The builds that the system uses are also automatically generated by the way. So this whole system is automated. The system automatically starts a build, it compiles the code, it fetches the game data, starts the autoruns, generates all the logs, injects the data into the central database, generates the automated report that I just mentioned, and then automatically sends it around in an email. It's quite handy. So far we've covered the importance of visualization and the usefulness of detailed logging and automated reports. This is already quite a powerful toolset, allowing us to have a picture on the AI's overall behavior in a time-efficient manner. But proper analysis cannot be done without actual in-game testing. And one form of in-game testing we use is loading into save games taken from autoruns. Because every autorun generates save games, potentially from every round of the game. These save games are only stored on the local machine, and it helps us to get a lot of extra information about the state of the campaign. Because as we load into the game, we can run extra, more detailed debug commands in our development console and get even more details about the AI's decision making and thinking. For example, if we loaded into a save game from this autorun that I showed before, we could check what Sun Jian was thinking about signing peace with Cao Cao during the invasion, and what were the main factors in this decision. I'm not going into details about how this part of the AI works, as that would be an entire separate live stream session, but we're happy to answer questions about it. The drawback with this method is it's very time consuming. So, because for all the other methods, we don't have to launch the game, we don't have to load into save games, it's very quick. This is more time consuming. So for this reason, we usually use this method when we already know that something went wrong at a specific point of the game, and we know exactly which save game to load in, which part of the campaign to load in. And this way we can get a lot of additional detail. The last piece of the puzzle, the thing that completes our toolkit for AI behavior analysis, is proper playthroughs. I mean, sitting down and playing the game the good old manual way. It gives us subjective feedback of our QA members, of our designers, programmers, and on Three Kingdoms we had regular playtest sessions for the entire team, and had lots of feedback meetings where we exchanged crazy stories about what happened in the game. And I often heard members of QA telling each other how the AI backstabbed them at the most tense moment of the campaign, and I was just standing there smiling because I knew what was going on in the background. While in other cases, it turned out that they saw a lot of seemingly nonsensical behavior from the AI, which didn't show up in autoruns at all. These things tend to happen because we can't simulate a human player properly in autoruns, which again highlights the importance of proper playthroughs and subjective feedback. To conclude this talk, our advice for analyzing AI behavior would be: gather as much data as you can to cover a large amount of possible game scenarios. Use autotests and automated processes to quickly generate the data and to flag up issues. Develop a diverse toolset, don't just rely on one method. Visualize your data. That makes it much easier to comprehend complex information. And finally, invest ample amount of time and resources into this. It's really worth it on the long run. So that's about it. And now it's time for some questions. Let's have a look at what questions we have here.
I can start with the first one.
Okay.
How long have you been using Cat in Total War, and how long does it take to create a tool like this? So, I think it's been 4 years since we've been developing Cat now, give or take. It's not in full development, but at the first year we sort of developed a base for it, and then between projects or whenever we find time, we started to add more things depending on what sort of features do we need. And yeah, we've been using it for like 4 years, but also it's a good idea to mention that this tool had a predecessor, which was another tool that sort of does some analysis, but not from the databases. It wasn't working from a central database. It wasn't enable us to analyze different games together, but it was a tool that would be taking a log file and analyze one game at a time. And it's developed by Tim, or lead AI programmer in the company. It's been there around like maybe 10 years?
Yeah, I think so. Yeah.
Give or take, but we sort of retired that and started using Cat instead.
So let's check the next question. Could a tool like Cat be useful in other genres of game development? Yeah, absolutely. I mean, I guess any game where you have a map, you will need to visualize what happened on that map, and you will need some sort of a very similar visual tool where you can display heat map. For example, if we talk about a shooter game, you can display heat maps on this with this tool. You can also do the same thing there. You can use a central database, collect all that data and visualize it on that map you have. So I could definitely imagine it for shooter games, for example.
Can you explain how Total War's AI works? So, yeah, I can just give a very broad overview. So, it's a very complex game, as I mentioned, and it has a very big search space. So how we tackled this is we find it very difficult to find a common big AI, big system that makes decisions in every area. Instead of doing that, I am trying to find the slide. Yes, there it is. We decided to divide this search space into different parts, and we tried to solve each problem in its own domain. For example, we have a finance system. Or let's start with some other system. For example, we have the army management system or task management system. That system is responsible on what sort of tasks there will be in the game. So the armies will pick up those tasks and do those actions. For example, they will attack to a region or recruit in a region and so on. That is decided in the task management system by itself, and it uses MCTS to search the space and find good plausible solutions. And for example, diplomacy system is using a utility AI system where it analyzes the world and decides how good it's doing, how good the others around doing, what sort of threats they have against themselves, or how strong its enemies are, and so on, and then picks the factions that are more important to do deals. For example, oh, I'm in a very bad situation. I really need to do some peace with some of my enemies. Otherwise, I'm just gonna die. So all these systems does its own decisions by different type of AI system. And there's a finance system on top of it, which decides how much money or how much resources each of those systems will get. So it is sort of an indirect control of each system. So it sort of steers all those systems in one direction. So is it a fair explanation?
Yeah, I guess in a sense we can say that the AI doesn't have like a central brain that decides the central plan and everything. We solve these issues one by one in different systems. So the diplomacy system solves its own issues, own tasks. Finance system solves its own problems, and there are a few concepts we have that holds these things together. For example, we have the concept of strategic context, which describes how much of a trouble the AI is at the moment, like how many enemies does it have compared to its own strength, and this strategic context affects pretty much nearly all the decisions that the AI is making. So we have some of these central concepts there, but otherwise pretty much each problem is solved in its own domain separately.
Mm-hmm.
Okay, so which one should we answer next?
You can go with the third one, maybe.
Okay, so we have a question that says, what makes a convincing AI in Total War? That's a really good question. It's kind of a classical design question. It needs to be human-like. So it has to have a proper personality. And if you can't implement this convincingly enough, then that's a problem, because all the factions, all the different AI opponents and potential allies will feel the same. So having a proper, strong personality helps a lot. That helps to build a convincing AI. We also make sure that the AI is playing the same game as the player does. So it's not something where the AI is playing some sort of a simplified version of the game. The AI makes, as Duygu said before, it makes the exact same type of decisions as the player does. So it has to solve the same problems. That makes it, I would say, that makes it quite convincing.
Yeah. Let's see.
Maybe the fifth one. I can just quickly answer that. And
yeah, definitely. There was another great question. That's why I'm
Let's go with that first, the one that you wanted. Let's do that first.
No. Okay.
We have so many questions here.
Yeah,
thank you very much for sending all these questions.
Yeah, and they're really good questions really good as ones. Well. Okay, I'm just going to read the first one, and then we can think about it on the run, because it's a long one. I didn't have time to read all. Can AI in Total War remember decisions from your early turns? If so, how do you manage AI that can remember so much data over a game which could be hundreds of turns long? Okay, so AI remembers, so be careful when you play. It doesn't remember all the decisions that they do. But let's say, yeah, it's safe to say we have a subset of decisions that we remember. We keep logs of the important things, like what sort of tasks the armies choose to do, or what sort of threats we had from the other factions, or we have a attitude system, for example. When you do something negative to someone else, that someone else remembers what you do over time, but it's not like from the beginning. So we can say there is sort of a horizon, and over time it neutralizes.
Yeah, things get forgotten basically. So, and also the AI remembers things like if you break a treaty with them or declare war on them, they will remember it for quite a long time. It depends on how we set it up. We can set a number of rounds, how long the AI should remember this, but yeah, the diplomacy system is probably the best example, because the AI needs to remember what happened in the past so that it can make good decisions about the present and the future.
And it doesn't make the same mistakes also.
Yeah.
And also another thing about this, maybe it's a good idea to mention a little bit about personalities. Factions have different personalities, and depending on their personalities, they will remember more or less. If, for example, it is a personality that is, what's the word
You have
for
resentful personalities
yeah.
who will remember negative events much longer.
Yeah, let's go to the next question.
So there's a question that says, do QA need to understand how the AI works? Yeah, that's a good question. Some part of QA should totally understand how it works, and some other part shouldn't really understand how it works, because we need people who are specialized on testing AI behavior. So they need to know how the system works. They need to how the different decision mechanisms work in the AI, so that they can test the system effectively. But we also need people who don't know much about these systems, and they can do black box testing, so they don't know what's going inside the AI's head. They only see the outputs. We need both, basically. So some part of the QA definitely need to understand how the AI works, but we need testers who don't understand it.
Maybe you can answer the third one in connection to that as well, because it's about playthroughs.
Yeah, so there's this question, how much of your time is spent doing proper playthroughs? Yeah, it would be difficult to quantify it, but on Three Kingdoms, we started playthrough sessions long before the release. So we had regular sessions every week. I think on Friday, pretty much everybody was just playing the game on Fridays, including many programmers, the entire game design team, and most of QA. And then we had regular, I think weekly meetings about discussing these play sessions. So, and we had a lot of these. So we did this every week for months. Yeah, it was very useful.
There's a quick one I will go for as a third one. Does the AI only make decisions based on factions that the AI has met, or does it sometimes receive data from currently unknown factions as well?
That's good.
Well, they only do their decisions based on the AI, based on the factions that they met, because when they don't know them, they're unknown yet, so they don't really use data that it doesn't supposed to know.
There's a question about the kind of difficulty, I guess. It says, how do you dumb down an AI for easier games? Do you lower grades for essential tasks and up others, or something completely different? So it's usually, I'm doing a lot of the AI difficulty balancing. So that's a really good question. In Three Kingdoms, there was one main focus point of the decision balancing, and that was basically the higher the difficulty setting is, the more the AI will see you as the player as the main threat. It's a simple multiplier on one value, and that changes the game so much in an organic way. I mean, it makes sense that if the player is playing on a harder difficulty setting, then that player is probably a bigger threat. So just basically this notion organically feeds into the AI's decision making, and on easier settings, the player is seen as a very low threat. It can still mean that if the player plays very aggressively and has huge armies, then the AI will see the player as a real threat. But this is the main kind of tweaker that we use for the difficulty setting.
Mm-hmm. I will go for the fourth one. Do you use different play styles, maybe human-like AI bots, for the Autotest feature? So, our game is a sandbox game. So we have AIs that makes decisions and play the game. We don't really have different types of play styles, because they decide mainly depending on the situation of the map and situation of what the others are doing. Every game, it creates a different dynamics anyways. So we just let them play as they are. Well, one thing we could do is actually try to simulate the one of the AI as player and try to define different tactics and so on, but currently we are not doing such things. Maybe in the future.
There was actually a point during Three Kingdoms, I think in the early stages of production, there was a point where we started experimenting with the different aggressiveness levels for the campaign AI. And there was a point where I basically set all factions, all personalities to be very aggressive in the game. That was just an experiment. And we checked auto runs, and we also did playtests on it, and it was highly successful. Basically, we had to prove to ourselves that we can make a really aggressive AI. And yeah, we quickly proved that we can do that, absolutely. So for that test, we kind of used some sort of we kind of simulated a play style, a very aggressive play style, but we didn't do. I think we did a few more experiments with this, but otherwise we just let the AI play these games without modifications usually.
Yeah, but at the end of the day, our goal with the Autotest is actually simulate how they would do in an actual game. So doing those helps us to develop some features of the game, or some improve some parts of the AI, but essentially we need them to be natural to see how the end game or how the general game will play out.
We have some career questions as well, if we want to have a look at that as well.
Sure.
Maybe the sixth one.
Yeah. Let's go with that. Why don't you start?
Okay, so there's a question related to careers, and this is, how did you both get into your careers? So I got into the game development, I think, more than 14 years ago. At the time I was studying programming, and I started as a QA tester in Hungary at a games company, and it completely sucked me in. So I loved making games, and for some reason I ended up being a game designer instead of a programmer. I guess I enjoyed the creative freedom, I guess. But yeah, I started as a QA tester. That's a pretty good entry point into the industry. Even if you want to become an AI programmer or a programmer or a designer, if your first job is in QA, it's really useful to learn all that knowledge. It still helps me a lot. So yeah, I started as a QA tester, and then I got promoted to a game design position after half a year, and since then I'm doing game design.
So for me, as a young adult or as a child, I really loved playing games. I was spending hours and hours and hours, and my mom was always getting angry to me, like, why are you wasting this much time in playing the games? Just do something that would be helpful in your career. And then I was like, wait a second. If I do that my career, then problem solved. I can just say I'm doing research and play games as much as I want. So that's how I decided. And then I studied computer science. And then I realized I'm really into AI. So I did my master's in AI. And then at that time I was living in Turkey, and in Turkey there are not really games industry. So I started doing some other things. I worked in a robotics company called Sunlab, which was a really nice job. And then I started going to conferences about AI and games because I was still reading a lot about it, and I was trying to write game AI in my free time and so on. And in one of the conferences, I met Creative Assembly, and they were looking for an AI programmer. I was really interested in doing AI in games. So that's how it started. And then I started here, and I've been working here for 4 years now. So if you want to get into games, it is a really good opportunity if you follow conferences, if you follow like important people in the field on social media and ask questions and try to find connections, and also do your own work, do your own projects at the same time, because when you can find that connection, you need to have a lot of things to show, like what sort of things you've been doing and what sort of things you're interested in and so on. Yeah.
Okay, that's the next question. Yeah, we still have so many questions. Thank you very much for all these questions. Okay, so there's a question about how close is the campaign AI related to battle AI? Yeah, that's a good question. These are two completely separate systems. There is some level of interface between them, but there isn't much interaction between the two AIs. So yeah, this is something that we're looking into, but there isn't a lot of connection. The battle AI has its own things. It has an objective at the start of the battle, and it's pretty much separate from the campaign AI. What we need to make sure in the campaign AI is to provide the players with interesting battles. So we try to set up the AI in a way where it mostly initiates battles that are more or less even, or it's not an obvious win or lose for the player, so that the battle itself will be interesting. But yeah, there isn't much connection between the campaign AI and battle AI.
Can you also save logs, data from QA playtests, and analyze those if something interesting AI decision happens that has not been caught by autotests yet? Yeah, so as Csaba mentioned, there are some CSV files that we output during a game, and these can be generated by autotests or by playthroughs. And yeah, it can be more or less detailed as well. There are like all sorts of settings for those. And yeah, that is really important to do that as well, because we have a lot of things that we cannot catch in a AI auto tests, but we catch them in a playthrough, because when the player does something, if something goes wrong, if they realizes something is off, the first thing we do is to go back to those logs and look what sort of things happened and try to dwell into those and find the actual cause of it.
Right, there is a question about diplomacy. How do you plan and create AI with some complicated diplomatic relationships like in 3K? So basically, how do we make our diplomacy AI? Oh yeah, it's a very
deep,
topic. Yeah.
big subject. I can quickly talk about the
Yeah,
technical
okay,
part, and then I can talk about
okay.
the design part if you like. So our diplomacy system is essentially, yeah, a utility AI system we can call. So what we do is we analyze the world, and we sort of try to understand where we are. And then we have a lot of designer data that defines what a deal is, and what sort of components there are in the world, and what sort of evaluation functions these components are linked to. What I mean by components, by the way, for example, if you form a deal to offer to a faction, if you add a non-aggression pact and money in it, non-aggression pact is a component and money is a component. And then AI generates loads of those deals. And then we go through one by one and evaluate them and try to understand how good they are. For example, we can look at what is the relationship between two factions, and that's one of the criteria. Or we can look what are the possible outcomes if we were to sign this deal. We will be in a very bad situation, or will we be in a better situation? Or if there is money or secondary components like ancillaries or region trading is involved, we also have a way of quantifying those. We look how much money we will gain, or how much money this item is equate to, and so on. And then we decide if a deal is favorable or not, and we sort them by these evaluation numbers, and we do a weighted random selection in between of those. And in the other way, if we are offered something, we follow the same logic. We evaluate it and see if it is favorable or not. If it is favorable, we accept it. If it is not, then we either counteroffer or we just reject it. And we also remember what sort of deals that we've been offered or we offered, so that we don't keep doing the same deals or same mistakes if it was a mistake in the past.
Yeah, we also have some logic in place to avoid the AI spamming the player too much with diplomatic offers. That's something that we try to focus a lot more on 3 kingdoms, to make sure that the player isn't overwhelmed by these offers. As Duygu described the system, we have a lot of different factors that the AI takes into account when it's making a decision in diplomacy, and pretty much everything in this formula is tweakable. So we don't need to touch the codes to change the AI's logic. We have a lot of tweakers and variables that designers can play around with and fine-tune the AI's deal evaluation logic, for example. And this system is highly data-driven. That's how we call it. So it's driven by these tweakers that are external to the code. So I can change these numbers around, make the AI much more reluctant to sign specific types of deals, etc., based on their AI personality. So we have this. So the general logic is AI generates these deals, evaluates them, offers them, and then remembers them. And then we can tweak all these with these hundreds of tweakers that we have in the game.
Also, one maybe additional thing to add this is, factions has personalities, and they have personalities when they generate the deals as well. So because we don't want super static deals that are done all the time the same way, depending on the personality of a faction, they usually generate different deals, or depending on their personality, they might evaluate them differently as well.
Yeah. Okay, so we have some more questions left. The next one is, do you use output from battle to create more balanced armies? We don't do this in an automated way, but we do get feedback from QA testers about how the AI behaves. So yeah, when they play battles, we get feedback from our members of QA if the AI was sending armies against them that were not good enough, that the army composition was suboptimal, or it was weird. So we get feedback from our testers, and we can adjust the AI's recruitment logic or army generation logic to fix these issues. But we don't really have an automated test for this.
Mm-hmm. I think that question would be too long to go over because we have. Yeah, sure. Go on.
So there's a question that says, what important factors are there for moving the armies? How does the AI evaluate possible army positions? So if I want to quickly summarize it, so the campaign AI has a higher level logic for figuring out which armies should do which objective. So the AI, this high level allocator, resource allocator, picks the various AI armies and sends them against specific targets. So the AI will say, this army will attack this settlement, that army will defend that settlement, etc. So this is the high level objective for each army. And then we have a lower level layer, which is called the coordinator, which is responsible for moving these armies around and fulfilling the objective. The coordinator has some freedom in making its own decisions. It may decide not to attack the target it has a objective against. But yeah, the coordinator system uses a Monte Carlo tree search to find the heavily modified version of the Monte Carlo tree search to find the best position or the best course of action and in the best sequence. And that's it. It basically evaluates as many possible options as possible within a time frame and tries to pick the best using this heavily modified version of the MCTS.
It's also may decide to do some cooperation between armies and merge some actions to use both armies together, for example, or it can do some opportunistic attacks along the way and so on. And the last question is, would you consider a future live stream to explain how the AI of Toth works? Definitely,
yeah.
Why not?
Yeah, that would be a good topic.
Mm-hmm.
So yeah, I think that were all the questions. Thank you for watching this BAFTA Games live stream, and watch this space for future creative assembly tutorials. Thank you.
Thank you very much.